Hello and welcome back to Apt4U. In this particular video, I am going to discuss a new problem from linked list, which is basically rotate a linked list, right? This particular problem is available on Geek for Geeks, so you may refer it. And basically, it is a very interesting problem, right? So the problem basically says that we are provided with a singly linked list, right, of size n, and we have to perform counterclockwise or anti-clockwise rotation by k nodes, and the value k will also be provided. So basically, we are provided with a linked list, and we will also be provided with the head pointer to the head node of the linked list, and a value k, right, which will basically indicate the number of times I have to perform the anti-clockwise rotation, and finally I have to return the head node of the output list produced. So let us understand this particular problem in more detail. So for that I will be just increasing the size of the code window. Okay, this is fine. So let us understand what basically the problem says. So basically, suppose I have example linked list 2, 4, 7, 8, 9. So 2, 4, 7, 8 and 9. Now we have to perform anti-clockwise rotation k equal to 3. Means k equal to 3 basically indicates by the number of nodes anti-clockwise rotation by 3 nodes. So which basically means that if I perform the anti-clockwise rotation by one node, so basically what will happen is this 4 comes here, 7 comes here, 8 comes here, 9 comes here, and this 2 will go there, right? First time. Second time anti-clockwise rotation, so 7 will come here, 8 will come here, 9 will come here, 2 will come here, and this 4 will go at the end, right? You can see, just assume that I am just pulling this towards right. In the third time what will happen? 8 will come here, 9 will come here, 2 will come here, 4 will come here, and 7 will go there. So you can see that rotating by 3 nodes. So each node has been rotated anti-clockwise by 3 nodes. So this is the output. You see, every node has been rotated anti-clockwise by 3 nodes. So basically what we can observe is, given a linked list, if they say that we have to perform rotate each node anti-clockwise by 3 nodes, right? So what does it mean? It means that you can see this entire part, these 3 nodes, okay, in the output linked list will come here, and this entire linked list 8 to 9 will come before. So I'm just giving you an intuition about what is actually happening, right? How am I going to code this particular problem? So first of all, we have to observe what is actually happening. So if you see, after k rotation, after 3 rotations, what happened is the first 3 nodes moved towards the end of the linked list, right? And the last 2 nodes basically came in the front, right? So this is the idea of this particular problem. We will basically first of all use the value k, right, to split this linked list into 2 parts. Finally, we will consider these to be the head node of the output linked list, and also what we will be doing, the next of this particular node will be made null, and this will be joined to this part. Getting the point? So we are going to do some steps of things. What are the things? First of all, I have to split the linked list by using the variable k. Secondly, I will define this particular node as the head node of the output list that will be produced. Then the next of this particular node, the last node of this previous split, will be made null, and finally the next of this particular the next of the last node of this particular sub linked list will be pointed to the head of the original linked list. I hope you got the point. So basically 2, 4, 7, 8, 9 was given, and if I have to perform k equal to 3, means anti-clockwise rotation by 3 nodes, what will I do is basically I will consider these 3 nodes and split it into a separate linked list, and this will be splitted into a separate linked list. Then what will I do? The next of this node will become null, right? This will now become the new head node, and the next of this will point to the head of the original linked list. And see, finally the output will be 8, 9, 2, 4 and 7, which matches with the expected output, right? So these are the steps that we are going to follow, and basically we are going to code this particular problem, right? So let us see how can we actually code this particular problem. So as I said, first of all, we need the help of certain pointers. So basically I will be writing struct node taking the help of 2 pointers, right? So p1 and struct node star p2, right? and P1 is equal to P2 is equal to head. So initially both will point to the head node. So okay, please just understand what is actually happening. I will be just doing the things parallelly. Okay, so I hope you understood the intuition that what I am going to implement. So basically just let me go parallelly. So the sample linked list here is 2, 4, 7, 8 and 9, right? And this is my head node that is given. So I am declaring two pointers, P1 and P2. Both are pointing to the head node right now. So what next? Finally, integer k is equal to 0, right? Let me just write it below. Why am I doing this? Because not k equal to 0. Suppose a variable x equal to 0. Okay. Now while x is less than equal to k. So what does it mean? Basically, while we reach this particular point, okay, this particular point, because k is equal to 3. So basically I want my pointer to land on this point, right? Considering 3 nodes. So for that, what am I going to do is, while x less than equal to k, just say x plus plus and perform p is equal to, not p equal to, p2 is equal to p2 of next. So I'll show you the working, what is actually happening. So see, initially my x is equal to 0, right? So I will enter and k is equal to 3. So 0 less than equal to 3 is true. So what will happen? X will become 1 and the pointer P2 will point to the next node. Means P2 now points to this particular node, right? P2 now points here. Now 1 is less than equal to 3, true. So increment 1 and this P2 will now point to this particular node. Getting the point? Again, 2 less than equal to 3 is true. Increment it and P2 will now point to this particular node. Getting the point? And finally, this is 3, right? So basically I don't want to increment this pointer further. So I should write here x less than k, right? Because I don't want this pointer to increment further. I want to stop here only. So you see, now x is equal to 3 basically, and it is less than 3. It is false. So we will not increase this any further. So which means that finally we have stopped the pointer P2 at this particular node where we want. So it's time to split these nodes into two linked lists. Basically it's time to split the entire linked list into two linked lists. So what will I do now? Now basically the next thing that should be done is, if P2 not equal to null, getting the point? So if P2 is not equal to null, means we have some elements there, then what we are going to do is basically we will say we will come inside first of all, and we will declare a new pointer, struct node star, suppose f head, which means final head, and this final head will be basically nothing but pointing to the pointer P2, right? Which means now we have a pointer to this node which is called f head pointing here. Now what we have to do is basically P1 will come till this point until P1's next is not equal to P2. Why am I doing this? Because I want to make the next of this to null, right? So I will do a loop again inside this, which will say while P1's next is not equal to P2. Okay, so what we will be doing is basically P1 equal to P1 next. So keep on coming forward, and what will happen? This will stop when P1 comes here. The moment P1 comes here, from here it will stop. So this is now my position of P1. So what will I do now? P1's next will be becoming null now after the loop exits. P1 next is equal to null. So what is the process? Basically now the next of this is pointing to a null value, right? Now what to do next? Now basically I will traverse this P2 from here till here until the next is found to be null. Okay, and then see what am I going to do. So again I will be traversing while P2 next is not equal to null. P2 is equal to P2 next, right? So this will basically move forward, keep on moving forward until it reaches the point 9, and once it reaches point 9 the loop will exit, and now we know that P2's next should basically point to what? So actually what is happening is P2 is coming forward and P2 will reach here and P2 will stop because next of P2 is null. The moment P2 stops at the end of this sublist, the next should point to the head node. So we will do write the same thing, p2 next is equal to the head node. Getting the point? And head node, because we know that the head pointer is already available at 2 and we have already made this null, so everything is ready. So this is the end of the code here. Now we had given a condition if p2 not equal to null, right? If p2 not equal to null. Why am I giving this condition? Because suppose if you have a linked list 1, 2 and suppose this is null. So what happens is basically I will get the using this. First of all, what happens, x will be the pointer basically starts from here, p1 and p2 are initially here. Now what happens is suppose k is equal to 1, right? So what will I do? X equal to 0 first, right? Suppose k is equal to 1 and this is the linked list given. Initially p1 and p2 are pointing to this particular head node. So x is equal to starting from 0, 0 less than 1, true, x plus plus. So x will now become 1 and the pointer p2 will now move to this particular node, right? Now 1 less than 1 is false, fine, no problem. So what's next? Now p2 not equal to null, then it is fine, right? What we can do? We can do these changes. So this will basically become 2 followed by 1 followed by 5, right? It is fine so far. But what is the problem? The problem will come when we have only one node followed by null, right? So in this particular point you see what happens is basically p2 will be pointing to null, right? If you follow this particular part, suppose again x is equal to 1. So initially x is 0, so it will come inside, x will become 1 and p2 will point to null. The moment p2 points to null, we will not go inside, because you see somewhere inside we are doing p2 next, and we know that null next will be leading to segmentation error, right? So basically I am using this particular condition here to face this particular situation when we will have only one node followed by null. So the moment we have only one node followed by null, what happens is p1 p2 are initially here, and once we enter this particular loop, so p2 will then point to this particular node, p2 equal to null, and once p2 equal to null, we know that this is the only possible node of the linked list, so better returning the head. That is why here in the else part we will return head, right? Head, that's it. So this is all about in this particular problem. Yeah, considering this particular point, we made p2 head equal next equal to head, it is fine, which means we made this particular the next of this particular node point to the head node. So basically now we have to return f head, because this is the head node of the output list. So basically you have to return here f head, right? Yeah, that's it. So I hope this should work. Let us compile this particular code. Let me just rub this entire work that we have done. Alright, so compiling it. Okay, somewhere typing mistake, p2 minus equal to p2 next. Yeah, this should be p2 equal to p2 next. Okay, again a slight mistake in typing. p1 next is equal to null. Where is it? Okay, this is actually p1 next. Yeah, so you can see the output is correct. Let me just submit this particular code. Finally, we have successfully executed the code, and I hope this video was very helpful and you got the intuition about how we can perform rotation in basically order n. In time complexity was order of n, right? Because we are just doing one complete traversal of the linked list. That was the time complexity. Considering the space complexity, it is order of 1, memory efficient, right? So yeah, that's all from my side. I hope this video was helpful. In case of any doubt, please feel free to put your doubts in the comment section, and please like, share and subscribe. Thank you.